Hello, my name is Jörg, and in this video I'll cover some key information about sterile injectables. Let's look at what these products are and how they're manufactured. A sterile injectable is a medication or therapeutic product that is administered directly into a patient's bloodstream or body tissue. They can be delivered in different ways. Intramuscular injection means injection into the muscle. Subcutaneous injections are delivered under the skin. Intravenous or IV injections are delivered directly into a vein. And lastly, intrathecal injections are delivered into the spinal column. Unlike non-sterile drugs, for example tablets, capsules, gels or aerosols, sterile injectables bypass the natural defense like the skin or digestive system. Delivering a product this way can be highly effective, but also increases the risk that any contamination may pose to the patient. And that's why sterile injectables must be free of any harmful microorganisms, particulates, pyrogens, endotoxins, or other contaminants. Protecting the sterility requires a specialized manufacturing process that's far more technically complex, highly precise, and needs to be carefully controlled. This means using sterile components, maintaining a controlled environment, and following strict procedures to prevent contamination at every step. There are two primary methods for manufacturing of sterile injectables: terminal sterilization and aseptic fill finish. Terminal sterilization relies on carefully controlled environments and procedures to reduce the risk of contamination during manufacturing, but actual sterilization occurs as a final step before the product is released. Typically, the product containers are sterilized by steam or gamma radiation. This can only be done with products and materials that can withstand either radiation exposure or high temperatures up to 121 degrees Celsius. But in many cases, that is not feasible. When terminal sterilization isn't possible, sterile injectables are manufactured through aseptic fill finish, including filtration as a sterilization method. This process must even be more carefully controlled, from compounding to bulk filtration to filling, including a final filtration at the point of fill. Aseptic fill finish requires advanced equipment and a deep understanding of complex processes, testing methods, and regulatory standards. That's it. Don't forget to leave a like and subscribe for future videos. And if you'd like to learn more about this topic, check our website. See you next time.